All right, one last demonstration I want to show you. This is my fish tank of science. It's basically just water with a little bit of powdered milk in there so that the light will scatter. So this I use to show why the sky is blue. So I've got my flashlight here, and if I turn it on, you can see a slight color difference in my tank. This end of the tank has a bluish tint to it, right? This end of the tank is more yellow. And if we actually look at my sun, my flashlight here, from through the tank itself directly, it's a little too much exposure. There we go. It also looks yellow, okay? So this is like our atmosphere. So when the sun hits our atmosphere, which is mostly nitrogen and oxygen molecules, it is just the right size. Those molecules will absorb blue light, right? The sun is white light. We got wavelengths we can't see, UV, all kinds of light coming out. But our atmosphere tends to absorb the blue light and then re-emit it. And when they re-emit it, it goes in all the different directions. So instead of coming straight at our eye from the sun, we get blue light coming from all the molecules in the air, and so the sky looks blue. The other cool thing is, if we have a polarizer, let's see if this will show up through here. If I rotate the polarizer, the reflected light decreases in intensity. Oh yeah, you can see it there. So it decreased, and now you see more of the scattering light. So scattered light isn't totally polarized, but it definitely gives us some preferential polarization. But that's only in the direction perpendicular to the direction the light is initially traveling. So the sun coming directly, light coming directly from the sun, if I put my polarizer in between me and the sun and rotate it, I don't see any difference. Okay, that light is unpolarized. But light that scatters sideways from the sun, perpendicular to the direction it's traveling, is slightly polarized, which is why, let's see, where'd my sunglasses go? Which is why it's nice to have polarized sunglasses. It's hard to do this so you guys can see. So polarized sunglasses also block some of that scattered light. So it's why the sky will look a little sharper and darker blue if you've got polarized sunglasses. Okay? So that's why the sky is blue, and this is why why sunsets are red. Because at noon, the sun is going through a short amount of atmosphere, right? The sun is straight ahead, and we get the blue light scattered. But at sunset, the light is going through a thicker layer of atmosphere. And so by the time the sun reaches us, we're standing over here and the sun's going through all this extra atmosphere, all the blue light's scattered away. It's all scattered away, and the only thing that's left are the orange and reds and yellows that reach our eyes. This is the same reason why during the fire season, right, last summer, our sky was this color, not this color, because like I said, I put a little bit of powdered milk, like a tablespoon inside here, and stirred it up so that the light would scatter and we'd be able to see the light. If I added a lot more, then the blue would disappear sooner, okay? And most of the light here would be yellow. So when we have smoke particles in our air, the blue gets scattered faster, and the only light that can get through all that crap is the yellow and red. So our sky was this horrible yellow, scary color last summer. Hopefully we don't get that again. So if you're on another planet with a different kind of atmosphere, it may preferentially absorb and re-emit a different wavelength, right? This is because our atmosphere is nitrogen and oxygen, which prefers to absorb the blue light. And it's called Rayleigh scattering. It doesn't mean the blue light just bounces off the molecules. It is actually absorbed by the molecule, then re-emitted, and it goes off in random directions. Okay? I think that is it for that. And I can also show total internal reflection with this tank. So I don't know that you can see it very well. It's still too bright. There you can see. So we've got the incoming light, it bounces off of the water-air interface, and it's all reflected. There is no light coming out at the top of the interface. Okay.